All right, welcome back, ladies and gentlemen. In this final video for 6.1, we are going to discuss some applications of vectors, and specifically, I would say we greatly see vectors in calculus with the concepts of velocity and speed. And so this is again a great prelude for those that are planning on going into some higher level calculus courses. So what is our velocity? Well, the velocity simply of an object is a vector, and the reason why is because velocity has both magnitude and direction, because the magnitude of velocity is that speed, okay? So that's kind of where we're going to start for today, is velocity and speed. So velocity is a vector because it kind of shows us the direction, whether it's going up or down, and then we have that component of how fast is a object moving up or down or left or right or whatever the case is, right, in the positive or negative direction, and that is going to be its speed, right, how fast it is moving. So let's take a look here about how can we write velocity as a vector. It says a DC-10 jet aircraft is flying on a bearing. Well, let me stop for a sec and highlight that word bearing, because we are going to come up to a little bit of an issue if we don't know what a bearing is. Now, the bearing of an object is not just simply its angle of measure, so be careful, okay? When you see this word bearing, it's also synonymous with the word or the term course, all right? So the course of an object or the bearing of an object is sometimes given as the angle of the line of travel that is measured, now get this, clockwise from due north, all right? Clockwise from due north. And so if you remember when we talked about in previous videos and previous examples, you heard things where it said maybe like 30 degrees east of north or 70 degrees west of north. That's the bearing. So in this example here, if you kind of imagine north, 65-degree bearing would be a clockwise rotation from north 65 degrees. Okay, so now let's kind of continue on with our problem. Now it says that is flying at 500 miles per hour. Well, ladies and gentlemen, that 500 miles per hour is our vector, okay? So this 500 miles per hour is our vector that we are going to be having. It has magnitude and direction. Find the component form of the velocity of the airplane. And again, it says recall that the bearing is an angle that the line of travel makes with due north. Okay, so let's think about this. This was our north, but I also want you to think about it's almost kind of like our y-axis, okay? That means that this guy down here would be our x-axis. And so, of course, this makes a full right angle. So that means that if this guy was 65 degrees, left over would be 25 degrees. So now this will help us out because we know that our magnitude, all right, its speed is 500 miles per hour. So that vector v is moving 500 miles per hour, or that's the size of the quote-unquote vector. So now we can utilize this information to go ahead and find what the vector is going to look like in component form. So now remember, we have ourselves our direction angle. So let's go ahead and see if we can go ahead and finalize what those A or horizontal or B and vertical components are going to end up being in the end. So we know that the vector a comma b can also be written in the form of v, absolute value or magnitude, times the cosine of the direction angle, and the magnitude times the sine of the direction angle. So I have the size or the magnitude at 500, and I have my direction angle, careful, is 25, not the 65, because you're always relating it to the horizontal motion or the horizontal axis, if you will. And then we have 500 times the sine of 25. Now, just because of you can leave it like this. I mean, you've answered the question, honestly, but just to kind of put, I guess, a little bit more context into it, I think it makes a little bit more sense to go ahead and to actually solve this out and get some numbers. So 500 times the cosine of 25 produces 453.15, and 500 times the sine of 25 gives us 211.31. So the reason why I wanted to actually write these on out, because this kind of helps really see what this is, because the components of the velocity here give both the eastward and the northward speeds. All right, so really what that shows that the airplane is traveling, right, at about 453 miles per hour eastward and about 211 miles per hour northward, and then that kind of acutes to 500 miles per hour at a bearing of 65 degrees. So that's kind of what the combination ended up being, right? So if you're going 453 miles per hour in an eastward direction and 211 miles an hour in a northward direction, what you end up kind of averaging, if you will, is a 500 mile per hour quote-unquote northeastern direction with a bearing specifically at 65 degrees east of north.